Today we'll show you how to determine biochemical oxygen demand or BOD of a water sample. Here we took a sample for BOD determination. BOD will be determined for both aerated and non-aerated sample. For non-aerated sample, the sample will be left as it is, but for aerated sample, we'll aerate the sample continuously. To dilute the sample, we'll use tap water, which is also being aerated constantly. To conduct this experiment, we need 2 BOD bottles for each sample. Here we have 3 pairs of BOD bottles. One pair is for non-aerated sample, one pair is for aerated sample, and the other pair is for the dilution water. First, we fill the BOD bottles of the blank, which is filled with the dilution water. The BOD bottles are filled to the full, so that when we put the stopper, there is no gap inside the bottle, and thus we can ensure there will be no air bubble. Then we will dilute the sample by mixing it with the dilution water. The dilution ratio will depend on the level of the BOD in the sample. After dilution, the BOD bottles of non-aerated samples will be filled up with the diluted non-aerated sample, and the BOD bottle for the aerated sample will be filled up with the diluted and aerated samples. Then we will put the stoppers of the BOD bottle and close the lids of the BOD bottle. Then we will put the BOD bottles inside an incubator at 20 degrees Celsius. We will put one BOD bottle from each of the samples into the BOD incubator for 5 days. Now the samples from the other BOD bottles will be used to determine the initial dissolved oxygen of each of the samples along with the dilution water. To determine dissolved oxygen, we will need manganese sulfate solution, alkaline potassium iodide solution, sodium thiosulfate, hydrochloric acid, and starch solution as indicators. At first, we will add 1 milliliter of potassium iodide to the blank BOD bottle and the BOD bottle of the test sample. Then we will add 1 milliliter of alkaline potassium iodide solution to each of the BOD bottle. After that, the stopper will be attached. After that, the solution will be mixed by inverting the BOD bottle several times. Then the BOD bottle will be kept as it is so that the precipitate can settle. When the precipitate settles to the halfway, we will do the mixing similar way again. After that, we will keep the BOD bottle again so that the precipitate can settle. When the precipitate settle up to the halfway, then we will add 1 milliliter of concentrated sulfuric acid to the solutions. After that, we will immediately insert the stopper and mix the solution as before. The solution will then kept at rest for 5 minutes. After 5 minutes, we will withdraw 100 milliliter of solutions and take it for titration. After taking initial burette reading from the burette, we will start adding 0.025 normality of sodium thiosulfate drop by drop from the burette until the yellow color almost disappears. At that point, we will add 1 milliliter of starch solutions and the color of the sample will turn into blue. Then we will continue adding sodium thiosulfate solution until the blue color just disappears. We will record the milliliter of thiosulfate solution used in this process, and then we will be able to calculate the dissolved oxygen as per the calculation procedure mentioned in the lab manual. In similar way, after 5 days, we will take the samples from the incubator and determine the dissolved oxygen, which will be the final dissolved oxygen. By taking the final dissolved oxygen and initial dissolved oxygen and appropriate formula from the lab manual, you will be able to calculate the BOD of the sample. Now we will show you how to determine chemical oxygen demand or COD of water sample. First we will show you the COD that is determined by potassium permanganate. To determine COD, we will need diluted sulfuric acid solution, standard potassium permanganate solution and standard ammonium oxalate solution. At first we will take 100 ml of sample into a 250 ml of Erlenmeyer flask. Here you can see that both aerated and non-aerated samples are taken into two separate Erlenmeyer flask. Then we will add 10 ml of sulfuric acid and 10 ml of standard potassium permanganate solution into the Erlenmeyer flask. After that we will shake the flask to mix the solutions. Then we will put the flask into a water bath for 30 minutes. The level of water in the bath should be above the level of samples inside the Erlenmeyer flask. After 30 minutes, take out the flask from the water bath and add 10 ml of ammonium oxalate solution into the flasks. Ammonium oxalate will first react with the remaining potassium permanganate in the solutions. After that, the remaining ammonium oxalate will be equivalent to the potassium permanganate that has been used during the oxidizing process of organic waste. Now quantity of ammonium oxalate remain in the flask will be the equivalent to the potassium permanganate that has been used to oxidize the organic matter. To determine the remaining ammonium oxalate, the solutions will be titrated with potassium permanganate. Potassium permanganate will be added to the solutions until the first appearance of the pink color. The pink color indicates the end point of the titration. Then record the milliliter of potassium permanganate used, and you can calculate the COD as per the calculation method shown in the lab manual. Now we will show you the COD determination using potassium dichromate. For this method we have a standard vial where standard solution of potassium dichromate are already in there. We will add samples of 2 ml into the vial. If the concentration of COD is high, then we will first dilute the sample. Additionally, we will also add 2 ml of diluted water into another vial which will act as blank. Then we will put these two vials into the COD reactor where we will heat the vials at 150 degrees Celsius for 2 hours. After 2 hours, we will take out the vials from the COD reactor and keep the vials to cool off. When the vials are at room temperature, we will take the COD measurement using spectrophotometer. First we will put the blank vial into the spectrophotometer and set the reading to 0. Then we will add the vial with the samples into the spectrophotometer and we will take the reading of the COD from the spectrophotometer.